So, hello, everybody. Welcome to the second live session on the Advanced Concrete Technology course. I'm Manu Santhanam, and I'm here with the teaching assistants for this course, Yuvraj, Sundar, and Vaishnav. They'll help me answer your questions that you have. We realize that it's getting close to the final exam date, and that would make it essential for you to look at the syllabus and look at any questions that you may have regarding the contents that have been done throughout the course, or any new doubts that may have cropped in from the last set of lectures. Okay, so what we'll do, just like last time, is first we'll take the questions that have already come in from the participants on the link that was provided, and then we'll come to the live session and take up questions in which have been formulated recently. Okay, so first, all right. So there's a question about the exam pattern and how to prepare for it. Okay. Of course, the exam pattern will be essentially multiple choice type questions. And of course, you'll have some questions which have single choices. Some questions will have more than one choice and so on. You may also have some calculations or some fill in the blank type questions, which again will be indicated in terms of the choice, and then you need to just indicate the specific choices. So it's entirely an objective type question paper. How to prepare for it? Well, what can I tell you? You can just read all the slides that have been given to you. Listen to all the lecture notes very carefully, because essentially what I've tried to do is test your grasp of the subject rather than specifically looking at the large tracts of information you may have memorized. It's more related to how you can apply the concepts that you've learned. Hopefully, you'll find the paper interesting, and all of you will be able to do well. Okay. Moving on, there's a question by Ram on geopolymer concrete. Of course, I'm not too clear about what the question is. Possibly this question will be raised during the live session later on. So I'll move on to the next question. There are questions related to how to prepare concrete subject for GATE. I don't really know. I'm sorry, but I guess the best way to prepare is to learn the concepts well enough. That's probably all I can say as a teacher. Mixed design procedure. So there's a question from Venkat Narayana on explaining mixed design procedure for self-compacting concrete. Of course, that's too long a question to answer right now, but I'll have to refer you to a guideline that is available on the internet. It's called FNARC, EFNARC, FNARC guidelines. And if you download this, you go to Google and type FNARC guidelines, you'll be able to download this document. It's a very well-written document by this European committee of experts from the academia and industry, which worked extensively on projects related to SAC. And they've come up with very nice guidelines as to how you can choose the kind of performance parameters you want for different types of structural elements, and how to go about the design process, what to do in case some tests do not come out correctly, and so on and so forth. So it's probably the best available guideline. Although there are many other books that have now been published about SCC, I would say that you can make use of this resource quite effectively, which is available for free from the internet. There's a question by Sarit Chandra on usage of hydraulic cement will be permissible to withstand against severe floods in the coastal regions like Kerala. Now, of course, please remember, cement is basically hydraulic. Okay, so cement is used to make concrete, and obviously concrete is a very highly durable and strong material, so it should be able to withstand disaster in any form, except that, of course, you need to design specifically for it. Where you want ductility, you obviously have to rely on steel. If you want basically strength and good abrasion resistant material, then concrete is a very good choice. We have a question from Vijay Krishna on despite having similar, I guess it means despite having similar chemical composition, how does the ultimate strength of OPC grades 33, 43, and 53 differ? Now, please remember, 33, 43, and 53 grades are given for cements based on the strength gain at 28 days. Okay, the strength gain exhibited by cement at 28 days. And you're not correct when you say that they have same chemical composition. They don't have same chemical composition. The compound compositions may be different in these cements because the cements are devised with different levels of tricalcium silicate, that is C3S, which is a primary early age strength contributor as far as cement is concerned. So for the cements which are higher grade, that is 53 grade, you generally will have a higher component of C3S. But sometimes you may see that the C3S and other chemical compositions may be similar for 43 and 53 grade, but still the fineness would be quite different. 53 grade cement will be having a higher fineness. In the long term, there may not be much difference in the strength of the concretes that you prepare with different types of cement. Please remember, this is only classification of cement strength, or cement grade is only pertaining to the cement mortar strength. In regular concrete, which can be designed to attain any specific 28-day strength, the long-term strength may not differ significantly. I'm talking about 1 year or 2 year strengths, assuming that you're continuously curing the concrete, will not differ based on type of cement that you've chosen. That is either 33, 43, or 53 grade cement. Okay. There's a question, general question from Tapesh on scope of concrete technologists in upcoming infrastructure industry. It's actually a good question, and I'm very glad that you're asking this, and I'm very glad that you're actually taking this course, because if you really look at it, many of our infrastructure companies, the companies that execute large-scale infrastructure projects, often do not have a team of concrete technologists. I'm not saying one person, but they need to have a team, because very often solving problems on site involves understanding of concrete technology. And the right kind of solutions can only be presented in a given situation by a person who is aware of the material science of concrete. So definitely, for infrastructure construction in the country, concrete technologists are a must. Syed Shahbaz Naqvi is asking a question on IS 456 table 11, column number 2, mean of the group of 4 non-overlapping consecutive test results. Okay. Now, please remember, this is for assessing the acceptance of the strength of concrete from a given batch. Okay. So non-overlapping consecutive test results. So that means you have several samples drawn from the concrete that has been supplied to the field. So when you take test results from these samples, the set of or group of 4 samples should actually give you the correct strength. Anyway, this is, requires a much larger discussion and interpretation of the clauses in the code. We can have a separate conversation if you want, but I guess at this stage, for the lack of time, I'll go ahead with the other questions. The other question is, why cube testing at 28 days for measuring compressive strength of concrete made a standard? Why not some other date? Okay. Now, I guess in the past, people worked in terms of weeks and months, and this was a convenient time period for people to assess the strength of the concrete. And in general, even looking at cement as a material for construction, it more or less attains about 80 to 90% of its ultimate strength at 28 days or 1 month, as the case may be. So we are used to working in weeks as far as construction is concerned. So that's probably why they looked at a cycle of 28 days and not 30 days. Okay, characteristic strength defines that strength of material by which not more than 5% of test results are expected to fail. Okay. Supposing we have 3 cubes of M30 grade, each having strength of 31, 32, and 29. I guess you want to know whether the characteristic can be said to be 30. Please remember, characteristic strength pertains to a statistical distribution of your strength results. If you look at the probability density function of the strength which is plotted, you should choose the characteristic strength as the value which is at the 5 percentile level. That means only 5% of the values fall below the characteristic strength. So if you have 3 cubes, you can't get the characteristic strength. With 3 cubes, all you get is a mean strength. And this mean strength, you need to check whether it is sufficiently higher than the characteristic strength. If you again go back to the normal distribution, okay, the 5% value will be to the left of the mean. Okay, that means less than the mean. So characteristic strength will be less than the mean strength by a certain value, which depends on the standard deviation of the results. Now, again, this concept, without really going into the details, it's difficult to explain immediately. But essentially, when you're designing for a characteristic strength of M30, your laboratory mean strength should be at least 38 to 40 megapascals. Okay, only then you'll make the grade for M30. In the field, of course, your actual strengths that you measure in the cubes that are supplied to the site, those should be meeting the acceptance criteria. And that's another set of criteria. But for the lab design, an M30 concrete should at least produce 38 to 40 megapascals at 28 days. Okay. So, I guess this question relates to the fact that there are two categories of fly ash, type C and type F, but in some of the results, only in many lectures, the word fly ash has been used. Okay. So please remember, unless otherwise specified, the term fly ash refers to the siliceous fly ash. That is the type F fly ash, low in calcium. Wherever type C is used, we give a specific explanation that it is actually a type C fly ash. The more commonly available fly ash is the type F, or low calcium fly ash. Okay, Vijay Krishna is okay. No, again, that question has been answered about difference in strength grades of the cement. Okay, there's a specific question pertaining to the assignment. I would let my TAs answer it separately in an email, if you don't mind. Okay. Saurabh Khandelwal has asked some questions related to fiber reinforced mortar. Whether load rate should be high or low for studying crack propagation in fiber reinforced mortar. Okay. Now, of course, load rate has to be pertaining to the specific test method that you're using to characterize the material. Okay. So if you're doing regular compression or flexural tests of mortar as per regular IS-based methods, you need to follow the same sort of a loading rate. The issue is if you want to test something like toughness or ductility of the fiber reinforced mortar, then you need to adopt strain or displacement control testing machines and have a very low rate of displacement, because essentially you want to capture the entire post-peak deformation characteristics also, because that's where a fiber reinforced mortar would differ from a regular mortar. We have had some discussion of this in the hardened concrete chapter. If you can look at the notes, that will explain to you how this is actually done. Is there any significant drying shrinkage in the case of fiber reinforced mortar? Again, please remember, when you do fiber reinforcement, you bring down the shrinkage. Whether it is significant or not, obviously depends on the type of mix design that you have adopted. Okay, so compared to a plain mortar, your fiber reinforced mortar will definitely have lower shrinkage, but significantly lower or not, I don't know, based on the water cement ratio you choose, the cement to aggregate ratio you choose, and so on and so forth. How to prepare samples for SEM and fiber reinforced mortar samples? What are the ways to avoid or minimize additional cracking during sample preparation? Okay, we have not discussed this in this subject, so I'll take this discussion offline. You can write me an email and we can explain to you the methodologies for sample preparation. Okay, again, you also have a question about investigating interaction between fiber and cement paste in addition to strength testing. Usually, fibers and cement paste interaction is assessed by means of pull-out tests of individual fibers. Not very easy to set up in the lab. You need very high precision testing machines and a good control to ensure that you're able to test the pull-off strength quite well. Is free drying shrinkage reliable if performed without humidity chamber? No, definitely not. You need to provide a constant humidity environment around your specimen to ensure that you're measuring the correct level of free shrinkage at a given relative humidity. So without a humidity chamber or without a room in which humidity is controlled, I would not advise doing a free shrinkage test. Okay, Shubham Sharma has a question. Sulfate present in SNF will not contribute to flash set. Also, how is it lowering the possibility of false set? Okay, please remember, when we are looking at the sulfates from gypsum, gypsum is present to the tune of about 2 to 3% by mass of your cement. Okay, 2 to 3% by mass of your cement. Your superplasticizer like SNF is already added at a dosage of 1% of the cement mass. And within this 1%, your sulfate content is going to be quite limited. Secondly, the sulfate is present in the structure of the polymer itself. So in no way is the sulfate from the superplasticizer contribute to the flash or false setting Of course, flash set, of course, sulfate is not really present at all. Okay, so you're saying that what if sulfate from the SNF is present? Will it affect flash set or not? So C3A reacting with water and with immediate hydration, that's called flash set. The sulfate which is coming in from the superplasticizer may be too small to really make any difference there. Similarly, in the case of false set also. Why do we say durability of lime-based mortar is more than cement mortar? From course, I feel durability is a property of concrete packing or particle size distribution. Of course, durability is a function of many factors, okay, including concrete mix design, water to cement ratio, type of binder, so on and so forth, and packing, as you rightly said. I don't know why you're saying that where you've heard that durability of lime mortar is better than cement mortar. It's not like that. It's just a question of the type of environmental exposure that lime mortar is subjected to as opposed to cement mortar. Durability has to be looked at with respect to the kind of application. So lime mortars are typically used for heritage structures. Now, in heritage structures, you need to provide for good breathability. There should be easy access for water in and out of the structure. Whereas in regular structures like infrastructure, where we use cement-based materials, we don't want water to penetrate the structure. So durability has to be looked at separately in these two cases. So it's not true that lime-based mortars are more durable than cement-based mortars. Both are equally good, except that cement mortars will set because of hydraulic nature of the cement. Lime-based mortars will set and harden only if they absorb CO2 from the environment. Quality control of fresh concrete. Now, I'm not sure what exactly is the question there, but of course, quality control of fresh concrete implies assessing the characteristics of the fresh concrete. Whatever workability tests have been specified have to be met with on the field. If you need a workability retention, that needs to be satisfied. You need to ensure that you need to look at the air content of the fresh concrete, the unit weight of the fresh concrete, temperature of the fresh concrete. These are all the aspects that you look at as far as quality control is concerned. Okay. The concrete specimens attains 100% of its strength when cured for... I'm sorry.
We discussed in our conversation.
Yeah, okay. Yeah, see, again, this question was specifically pertaining to one of the slides, one of the graphs in the slide. Okay. Now, concrete does not attain its 100% strength at 28 days. Concrete continues to attain strength for a long, long time, as long as you provide continuous curing. Okay, please remember, concrete will continue to attain strength for a long time only if you provide continuous curing. It does not stop at 28 days. It continues to gain strength. Okay. The graph is just an indicative graph which compares the strength at 28 days with the strength of concrete cured at 28 days with the strength of other types of curing. That's all. The typical amount of calcium oxide in ricer's ash is dash.
Most option we have is listen.
Yeah, so see, the assignment gives you options based on certain ranges. Okay, the range which you need to select is less than 5%. In the lecture, of course, I've given it as 0 because it was from one particular analysis for the ricer's cache that was provided. It's not really true for all ricer's caches. There may be some calcium present, but generally it's of a very low amount. Okay, so that ends the kind of that ends all the questions that were already sent. Now, I guess we've already got a lot of questions in the live session itself, so I'll try to catch up. Okay. There's a question about what are the job and startup opportunities for a fresh civil engineering graduate. I guess there are too many answers to this question. I hope that you get the right opportunities that you want at the end of your graduation. I can help you privately on that. I can give you some advice on that, but I guess this session will stick to answering questions about the course itself. Okay. One question on, I want to do a PhD on concrete. Can you refer some topics? Because there's a lot of topics on concrete. Some of the pressing topics obviously are how can we extend the use of binders which are non-cementitious, for example, increasing the level of limestone or calcined clay or fly ash or slag in the cementitious blend without compromising on the different characteristics of the concrete that you want. Fresh and hardened concrete characteristics, durability, and so on. Because we want to extend the life of the limestone reserves, which the cement companies utilize to produce their cement. There's a lot of excess limestone also that is not usable for cement clinker manufacture, which is wasted by the cement companies. They really want to find a good use for it, and that may be another scope of research. That will be a good resource conservation based research that you can do. Alternative aggregates is always an ongoing research as far as concrete technology is concerned. But we need to look at more specific research questions that we should be asking, not just the question of how much sand should I replace by this material to get fine aggregate in concrete. Not like that. We need to understand what are the particle shape and size characteristics, but that will affect fundamental concrete characteristics, okay, and explore the kind of questions that needs to be answered, okay. All right, so why is the Shubham Sharma has a question? Why is slag considered as a hydraulic cement? So please remember, hydraulic cement is a material which can react with water on its own, even in moist, and set and harden even in moist conditions. Now, slag on its own can react with water, but as I said in my lectures, it takes a long time for that to happen. If you do an activation, it happens very fast, because that's why slag is given a term as a latent hydraulic binder. Okay, it's got hydraulicity, but that hydraulicity needs to be brought out by the help of a suitable what sort of chemical? I forgot. Activating chemical. Sorry, an activator. You need alkalis and sulfates basically to activate the hydration of the slag, and that generally happens very well in the presence of Portland cement, because cement contributes the alkalis and sulfates. And of course, you also have alkali activated slags, in which case you don't really need any cement. The alkali is provided directly by the alkali activating materials, which sometimes is given the term geopolymer, which is not correct in the case of slag, because you have alkali activated slags and then you have geopolymers, which involve other type of siliceous and aluminous materials. There's a question: can I use your data for presentation where I would like to give presentation on durability and use of different cement? Yes, you can use the data, but please do provide a reference as to where you got it from, because it's good to always, whenever you present any data from others, ensure that you are referring to the data whenever you make the public presentation. Thank you. Okay, somebody wants to ask a question about fly ash concrete bricks, but if you can ask the question, it will help. I'm not sure what question it is. How will rebars affect the creep in concrete? Okay. Now, of course, please remember, creep in concrete happens because of internal rearrangement of the structure in concrete, and also to some extent because of drying. Okay. When rebars are present in a structure, the rebars are not undergoing creep at the same rate as the concrete. Rebars are made with steel, so steel creeps much lower than concrete for the kind of service loads that the structure experiences. Okay, so there is some differential rate at which concrete and steel are creeping there. So there are some chances of differential strains being created. Secondly, if there are any issues of stress concentrations that arise because of sustained loading, the steel will help to actually sort of redistribute some of these stresses, which lowers the effect on the overall structure. But yes, steel bars may or may not have an effect. And a compression member, of course, the quantity of steel available is not sufficiently large to truly affect the kind of creep that the concrete is undergoing. Okay, but redistribution of stresses, whether cracking will happen or not, a lot of the factors can be controlled to some extent by steel. But of course, that's not a complete answer. Probably it needs a little bit more understanding and investigation. I don't really have at this point of time. Okay, curing of fly ash bricks. How many days will be required to achieve this strength? Now, again, please remember, it depends on what you mean by fly ash bricks. There are different types of fly ash bricks. Okay, there are bricks in which fly ash is used as a substitution of clay. Okay, so clay fly ash bricks. Sometimes the fly ash and the clay are burnt intimately also to make the brick. In some cases, fly ash is simply used as a replacement for cement in a concrete brick, which is the one which is used all over the place. We use fly ash concrete bricks. Okay, so depends on what type of fly ash that brick that you're talking about. Curing, obviously, if it's a fly ash concrete brick, you need to cure it for 40 to 28 days to achieve the required strength. If it's a fly ash clay brick, of course, the kind of processing that you do for regular clay bricks should be good enough to do with clay fly ash bricks also. How to do moisture test of sand? What method ISCs? Of course, you need to look at the method directly yourself in the IS stipulated guidelines. IS 2386 is the standard to look at for determination of moisture content. One second, just go back up. Yeah, so moisture test of sand, I guess you mean moisture absorption. Okay, so all that is very clearly given in IS 2386. But anyway, the test is too simple. There's not, you don't even need to refer to specific codes except for understanding how when to carry out the test and so on. Essentially, you need to take a moist sand and just put it in the oven and dry it completely until the weight is consistently similar. That means there's not much difference in the weights that you take on one day and the next and so on. So the clear stipulations are given by the code, obviously, but yeah, it's a fairly simple test to perform. You only need an oven which goes up to 105 degrees Celsius. Okay, why do we need testing for drying shrinkage? Now, of course, please remember from our lecture slides that drying shrinkage is very important from the point of view of how the concrete will perform in the long term. And whenever there is a restraint to concrete shrinking, it will create cracking in the structure. And cracking in the structure, while it may not become structurally important, it may be important from the point of view of durability. So we don't want cracks in the structure. For that, we want to minimize shrinkage. And minimization of shrinkage obviously means that you should understand how much shrinkage is there in the first place. And you can do some simple calculations to see what level of shrinkage will lead to cracking. And that's why you need to actually measure shrinkage. That's why drying shrinkage needs to be actually measured. Sorry?
This is answer.
Yeah, sure.
Scope of NDT.
Somebody has asked about scope of non-destructive testing to do a startup in Nagpur. Now, of course, please remember NDT is used in the case of assessment of the structural characteristics of the material, as well as structural characteristics of the material in a non-destructive fashion. When you don't have clarity about the kind of strengths that the concrete has or the structural integrity itself, you can do some non-destructive testing. Scope is very good because there are a lot of agencies which need such testing to be done on their sites, but the number of labs that are actually doing this are not too many. Of course, you need to understand that NDT has to be done properly, and you need to understand the limitations of each of the tests. Very few of the NDT tests can actually give you quantitative information. So what you need to do is use a judicious choice of non-destructive and partially destructive tests to figure out the material characteristics. How to use natural fibers in concrete is a question by Amit Chauhan. Of course, any fiber in concrete will be simply admixed. So while the concrete is being mixed, the fiber will be put inside the concrete mixture. Now, natural fibers can be similar to synthetic fibers, except that in some cases, the natural fibers may not withstand the alkaline environment of the concrete. So you need to do proper assessment of that first, whether the concrete alkaline environment is still conducive for the fiber to act properly. And secondly, of course, you need to test the fundamental properties of the fiber, the strength of the fiber, the aspect ratio, whether it produces a good bond with the concrete or not. Okay, so as long as you have all those records and you understand that the fiber will not deteriorate in an alkaline environment, some fibers are known to deteriorate. For example, some untreated glass fibers will obviously interact with the alkalis, and that will lead to a destruction of the fiber's properties. Sometimes basalt fibers are also known to get deteriorated in an alkaline environment. So you need to be sure about what type of fibers you're using. Are they producing the required interactions that you want in the system or not? Why is the sample kept in water for 24 hours in the soundness test? Now, of course, you're talking about cement soundness test here, which relates to the expansion of the cement upon hydration. If it has too much free lime or magnesia that reacts with water and leads to the formation of calcium hydroxide and magnesium hydroxide that are responsible for the unsoundness. Now, of course, at the time that this reaction is taking place, we don't want water from the cement paste to start drying out. And that's the reason why we keep the system underwater. And we are also able to keep the temperature of the system controlled by having it in a water bath. Okay, which type of cement is very good for fly ash bricks? Now, again, I guess because of this, I get to understand that you're talking about fly ash concrete to prepare bricks. Okay. Now, of course, you can use any type of cement there. It doesn't really matter. Whatever cement is available. But for a brick application, I would not really go with a very high grade cement. You can definitely work with even a 43 grade cement. Should not be a problem. Any cement should be okay. I don't think there's a restriction on the cement type to be used for a fly ash concrete brick.
Excel for mixed design M20.
So somebody wants Excel sheet for design of mixed design of concrete. Of course, now these days you even have apps available on the mobile phone to do concrete design for all kinds of other things related to concrete. Also, I'm sure that you'll be able to find something suitable for yourself. Or otherwise, of course, you obviously have the code to help you start. The codal guidelines given in IS 10262 will help you start off your mixed design process. Nothing will work, obviously, without good trial mixing. So you need to do good trial mixing to ensure that you're able to get the kind of properties that you desire. There's a question by Yuvraj Jadhav about which cement is mostly used in the industry. Now, that depends a lot on the application. In most cases, for residential building construction, you cannot get any cement other than blended cement. So mostly you'll be getting PPC, Portland Pozzolan cement, for residential construction. For infrastructure, mostly you'll see a combination of either 43 grade cement or 53 grade cement being used. In several circumstances, PPC is also directly used, or fly ash is used as an additive in the concrete. In many marine applications, Portland slag cement is used, PSC is used. Oh, there's a question on how to improve ITZ in concrete made with recycled aggregate. Now, of course, recycled aggregate will have some parts of mortar or paste sticking onto the aggregate surface also, okay, which is the reason why it provides high water absorption. Because of the same reason, it will also actually improve the bonding with the cement paste in the concrete that is produced with the recycled aggregate. Now, the issue will not be as much the bond between the new cement paste and the recycled aggregate. The issue will be more related to the fact that there's mortar pieces sticking onto the aggregate, and that interface may still be quite weak. But we don't know about which interface will crack first. But the bond is already very good. Otherwise, you can use aggregates which have already been immersed in a cementitious slurry, and that will again further improve the bond. But you don't really need to do that. I don't think bond is a major issue as far as recycled aggregate concrete is concerned. When you when you test the recycled aggregate concrete in compression, the cracks generally may tend to go through the original mortar aggregate interface rather than the new cement paste aggregate interface, in my opinion, because I feel that the availability of very high porosity on the cement mortar surrounding the aggregate will actually improve the kind of bond that you get with the new cement paste. Okay, there's a question on what is the need for developing ternary packing of aggregate. Explain in what type of concrete this ternary packing is adopted. List some application. Of course, I talked about this in the lecture itself. Ternary packing is essential when you want to look at optimization of the particle packing for concretes of very high grades. Okay, when we are looking at either strength or durability as a criterion that we need to meet in the concrete. So mostly what you'll do is have a ternary combination of the aggregates to ensure that you get minimum voids. That will also help you minimize the amount of cement paste that is required to give you the right workability. In almost all the large construction projects, infrastructure projects where high grades of concrete are desired, people adopt some way or the other of designing concrete mixes with optimized particle sizes or optimized proportions of different particle sizes. Now, ternary packing aggregate, I would not just say for high grade concrete. You can do this for any concrete. Just even M20 concrete, you can minimize the amount of cementitious paste required to produce the required strength if you're doing ternary packing with your 20, 12 mm, and sand. If you do ternary packing, you can definitely minimize the amount of cement paste required to produce the workability.
Can we predict the life of the structure?
Okay, the question about how we can predict the life of the structure based on durability tests in number of years. Now, of course, we've not had an extensive discussion on this in our durability chapters, but I did mention to you that there are models available like Life 365, which can calculate the service life or time to initiation and some level of propagation of the corrosion based upon the initial mix design process. I mean, basically dependent on the water to cement ratio, the level of replacement of the cement by the binder and by the alternative binders and so on. Alternatively, you can also measure the diffusion coefficient of the concrete and feed that as an input into this Life 365 design process. Okay, so Life 365 is another useful software that you can download for free from the internet. And this software can be installed in your computer, and you can run through various scenarios of choice of different types of cement-based materials, mixed designs. And if you have actually developed durability parameter testing in your laboratory, and you actually measured durability coefficients like the chloride diffusion coefficient, that can be directly fed in as a parameter to determine the service life. Of course, please remember all these are just models. No model will give you the definitive answer, but it's a good way to do material selection, to find out what type of material combinations, what type of concretes would be suitable for a structure to produce good quality concrete in the long run. Which admixture is used for self-compacting concrete? Of course, we've had extensive coverage in our chapter there on fresh concrete. So self-compacting concrete is generally produced with a super plasticizing admixture, obviously. But more important than that, you need to have a good level of fillers in your system also. Sometimes when you're working with low powder contents in the concrete for producing SCC, because of the tendency to segregate, you might want to use a viscosity modifying agent also. LC2 production, whether it's been started, if yes, where we can get an availability. Please remember, LC3 is not yet a commercialized cement. Okay, limestone calcined cement is not a commercial cement. It can become a commercial cement only after it gets standardized by the Bureau of Indian Standards. That process is underway. So the cement itself will be available only after the standardization is done and cement companies come forward to actually produce it. LC2, which is a combination of limestone and calcined clay, as an admixture, again, it's something that needs to be assessed and certified as per the BIS. So if you look at BIS IS 456, clause 5.2 in the materials section, talks about all the additives that can be used as cement replacements. So if you look at limestone, which is already used in cement manufacture to some extent, you also have calcined clay, which is permitted as an additive, or metacolin, which is permitted as an additive. So you can actually make ternary blends of limestone and calcined clay in the form of metacolin and still have LC2 in your concrete system. So per se, LC2 as an admixture is not yet manufactured, but that will happen in some time. Okay, there's a question about why would GFRG panel construction method, why is it not popular in India? I'm not sure why you're saying it's not popular, because nearly about 8,000 houses already have come up with this technology. And there's a lot more push by the Ministry of Housing to bring this technology to all corners of the country. In fact, this technology has just been introduced in the schedule of rates of CPWD. So because it's found a mention there now, I'm sure that it will appear across all over the country, and then definitely more people will use it. Okay.
The chloride presence main reason for concrete is only the chloride presence.
Okay, question: if the chloride presence in concrete is a main reason for concrete deterioration. Again, please remember we talked about the fact that concrete is subjected to different type of exposure environments. Okay, only when it's subjected to a marine or a coastal environment, we get chlorides in different forms. Okay, we get chlorides which are directly from the sea, or sometimes as airborne chlorides when high humidity actually carries the chlorides for long distances into the land. Okay, so chloride environments are pertaining to where you can find sources of chloride. Sometimes even groundwater may have chlorides. For example, in a city like Delhi, which is so far away from the coast, several structures get damaged because of excessive groundwater chloride. Okay, so chloride is just one form of deterioration. You can have other forms of deterioration like sulfate, carbonation, acids, like we've discussed in our chapters on durability.
Durability 2 is next week. So.
Oh, sorry. So that chapter probably has not yet been covered, and you'll have that video coming up next week.
Internships.
There's a question about if there are any research internships on concrete at IITM. We do get research interns from several colleges that come here in summer, sometimes even in the winter during the month of December. Of course, some internship programs are formal programs through IIT Madras. That is called the Summer Fellowship Program. That usually is advertised sometime in the month of February or so. So that's intended specifically for students who are who have completed 3 years of their bachelor's program or 1 year of the master's program, and you have to be having a very high standing in your department, okay, in your college, and then we consider those applications. The competition is very strong. We get very large number of applications, so please apply early enough, and we'll consider your application in that case. Scope for research on geopolymer concrete. Again, scope is quite vast. You need to read the relevant research papers that are coming out today. The aspect that people are mostly interested in working on is how we can reduce the corrosive nature of the alkaline solutions. That can only be done by using lower and lower strength of the alkaline solutions. At the same time, what are new inorganic materials, aluminosilicates, that can be utilized to produce geopolymer? So there are a lot of industry byproducts or waste products which have required chemistries to be used as geopolymer. So that's one aspect that is a good scope for research as far as geopolymer is concerned. The other obviously is to look at whether you need to modify any of the design codes when geopolymer concrete is used as compared to regular concrete because of its difference in durability, its difference in shrinkage behavior, and so on and so forth. So macro characteristics, performance characteristics of the concrete also need to be studied to a large extent. There's a question from Deepika on the use of CSH for seeding, for acceleration using CSH. Okay. Now, of course, this is something which is a new research that is happening across the world. And in fact, certain industries like BASF have also come out with products for seeding cement hydration. So when you provide nano or microparticles inside the cement paste, they provide very large surface areas. And these large surfaces are then sites on which cementitious materials can hydrate. Okay. So the presence of micro or nanoparticles helps to provide surfaces for seeding or acceleration of the hydration to take place. So CSH obviously is, as we discussed in our chapters, is a material with a very high surface area. So if you're able to somehow synthesize CSH and put this into the concrete mix, it will again provide active sites for nucleation of the hydration products. And since the product is similar to the seeding material, the possibilities of this happening are much greater than providing other nanomaterials inside the system. So CSH is being actively used as a seeding material. This can have vast applications in regions like cold regions where you need to accelerate the cement hydration, for instance. And that's a definite possibility where seeding with CSH can be done. Which types of Dhaval Parekh has a question. Which type of concrete can be used to prevent nuclear shielding? And can I go for my final year project, implying can you work on this subject for your final year project? It may be a little difficult to work on this subject for a final year project because the kind of concrete that you use for nuclear shielding obviously is high density concrete. And for that, you need to get high density aggregate. Now, getting high density aggregate is not very easy, especially because most of the aggregates which are high density, which are used commonly in the industry, are iron-based aggregates like hematite or magnetite. And getting samples of that is very difficult for research because most of these are either directly sent off to the atomic industry or obviously because of the potential to extract iron from this iron ore, it's much more profitable to sell it off to a steel industry. So it's definitely a good topic for research, but maybe not viable because difficulty in procuring the materials is very large. Use of nanosilica in concrete. Now, of course, we talked in the course about use of microsilica. These days, you also get nanosilica, which is basically colloidal silica, which is present in much smaller sizes as opposed to your regular microsilica. Now, as far as India is concerned, extensive research on nanosilica usage in concrete has happened to some extent at the CBRI, Central Building Research Institute in Roorkee. They have also produced a lot of literature on nanosilica usage in concrete. In IIT Madras, we have not really done too much research on nanosilica. However, just to give you a glimpse as to what it can do, of course, the nanosilica will also provide you very high pozzolanic reactivity because of the nature of the reactive silica. The difficulty is how well you can disperse this into the concrete system. If you really want to get the advantage of the very fine particles and very high level of pozzolanic reactivity, you need to ensure that these particles of silica don't get agglomerated. Because they are nano-sized, the possibility of agglomeration is very large. So you need to disperse it quite well. First, use a dispersing agent, then use ultrasonification to ensure that you're able to disperse this properly into the concrete medium. So that, in my opinion, is the challenge for any nanomaterial to be used in concrete. In fact, with the kind of mixing methods that our concrete producers have, and the kind of mixing schedules that they have, the use of even microsilica sometimes may not result in appropriate dispersion to really get benefited from the fine micro-sized particles of silica fume. So really, we need to do a lot more understanding of the ways of dispersion as far as nanosilica is concerned. But of course, in terms of positive properties, the enhancement of the strength and durability can happen with nanosilica. Interval of taking compressive strength of fly ash concrete bricks. Of course, if they are fly ash concrete bricks, again, you're looking at 7 days, 14 days, 28 days, like that. And I guess since you're going into production of the fly ash concrete bricks, you need to optimize the brick performance based on the strength. So whichever is the suitable age as far as your concrete bricks are concerned, you need to consider that. Use of slag dust instead of sand, I guess. I'm not sure what you mean by slag dust. I presume it means the fine-sized slag particles that are. I'm not sure what you exactly mean by that. I guess you mean finer slag or slag which is crushed to a fine aggregate size. Now, yes, of course, that's a very good aggregate also. But then, of course, you can produce a much better material from slag by quenching it. Okay, please remember, if you want to produce aggregate from slag, you'll have to slow cool it. Okay? If you produce ground granulated blast furnace slag, you are quenching it. That introduces reactivity in the slag. So, yeah, you can use it if it's available in plenty as an aggregate, provided you slow cool it, okay, and crush it to sand size. But otherwise, as an aggregate also, it's very good because slag is very hard material and it provides you a very high abrasion resistance. Question about what is the average creep coefficient of concrete? Of course, I don't have the numbers offhand, but the IS 456 actually gives you some sort of a value to assume for the creep coefficient. That's the ratio of the creep strain to the elastic strain in concrete. Okay, based on that, you can sort of calculate the extent of creep. I may have the result in my chapter also. I think I have covered that in my chapter. I don't have the number with me right now. Okay, question about how to use chopped glass fibers in concrete tiles. Okay, now again, chopped glass fibers will have to be mixed into the concrete before casting the tile. I guess that's what you'll have to do. The only thing is, fibers are going to be randomly oriented. In the case of a tile, obviously, they'll be oriented in the XY plane, right? And obviously, that will help you improve the performance against flexure or bending or whatever for the tile. Yeah.
Admixture for cement grout to avoid shrinkage.
What type of admixture is required to add to cement grout to avoid shrinkage? Okay. Now, for avoiding shrinkage, there are two options. We can use a shrinkage reducing admixture, okay, that can reduce shrinkage, but it won't avoid it or completely overcome it. Okay, shrinkage reducing admixtures, again, we have covered that in our chemical admixtures chapter. The other aspect or other way of avoiding shrinkage completely is the use of an expansive agent like a calcium sulfoaluminate additive. Okay, that can be used as a small fraction of your cement, about 10%. You can use CSA, calcium sulfoaluminate additive, that provides for expansion in the early stages because of formation of ettringite. And the subsequent shrinkage that happens in this material results in almost zero change in overall length. So you have early expansion followed by shrinkage instead of directly shrinkage, as you see in case of normal cement paste.
Design for pervious concrete.
Okay, suggest a reference for how to do mixed design for pervious concrete. The best methodology would be to become a student member of American Concrete Institute. Okay, you get free memberships. Students get free memberships in ACI, and there's an ACI document for pervious concrete. I forget the document. As a member of ACI, you get to download at least 3 documents for free. Maybe now it's different. Maybe it's more. So become a student member, download the document on pervious concrete. I think it's ACI Committee 522, if I'm not mistaken. But please look at it. Yeah, 522. Yeah. So 522 is the number of the committee. So 522 committee has actually produced a report on pervious concrete, and that gives you all guidelines about pervious concrete preparation as well as testing. Okay.
What is softivity test?
What guideline should I follow to make high compressive strength to be replaced by 25% fly? I guess you want to make high strength concrete with cement replaced by 25% fly ash. You can definitely do it. Please follow the guidelines that we discussed in the high performance concrete chapter. Do optimization of your aggregate blends, do optimization of your water powder ratio, use a good quality super plasticizer. I think you should be able to easily get high strength concrete with 25% fly ash. The question on what is softivity test? Softivity indicates capillary water absorption. So it's one-sided water absorption. So you have a dry concrete which you place on a tray of water, and water simply enters through one side of the concrete. Okay, that's called softivity. So essentially, mass of the concrete will increase as the water is absorbed by capillary action into the concrete. And this mass increase is actually plotted against the square root of time. You get a linear relationship, and you get the slope of that curve as slope of the line as softivity index, or rate of absorption, or softivity. Where are geopolymer concrete used? List applications. So again, please remember, geopolymer concrete is only intended to be a concrete in which the cementitious part is the geopolymerized inorganic aluminosilicate. Okay, so technically speaking, geopolymer concrete should be possible to be used wherever regular concrete is used, except that it's not yet fully commercially viable because people have not yet produced geopolymer concrete in very large volumes. There have been some applications like in Australia, there's been an application where an entire airport tarmac, including taxiway, was actually done completely with geopolymer concrete. Okay, so there are applications where this has been done. But essential idea is to use this wherever regular concrete is being used. Generally, lifespan of building is around 50 to 60 years. Is it not necessary for high-rise building to have a minimum lifespan of 100 years? Of course, it depends. It depends on what the owner of the building really desires, right? Because the owner of the building will have a stipulation of what is the desired lifespan of the building, right? And based on that, the design needs to be done. So it has to be designed, or it has to be defined by the owner of the building.
Durability of steel fiber reinforced concrete, RCPT or chemical image.
Okay, there's a question on how to measure durability of steel fiber reinforced concrete or hybrid fiber reinforced concrete, presumably one that has steel in it. Should I use RCPT? Definitely, RCPT should not be used, because RCPT is, as I discussed in the class lecture, it's more or less a conductivity test. So if you have steel fibers in the concrete, they're going to increase the conductivity. You're going to get very high values for steel fiber reinforced concrete. So you can use other types of tests that we've talked about in the class. I guess that lecture has not yet been seen by you with the different durability test methods. Maybe it's running this week itself. So this there's a sorptivity test, there's a water absorption test, there's a water penetration test. All these tests could be quite useful in determining durability characteristics of hybrid fiber reinforced concrete.
Control low strength material which are flowable.
Okay, I guess we are sort of at the end of the session today. So there are some additional questions which we can answer on the forum directly. We only have about 2 or 3 questions remaining, but we'll take these up on the forum directly and provide the answers there. Okay. So again, I'd like to thank you all for raising very interesting questions. I'm sure that you'll have more in the next couple of weeks before your final exams, but please do make use of the forum. And our TAs and myself will try our best to answer all your questions. And I wish you all the best for the exam, for those of you who are taking the exam. And goodbye to all those who have registered for the course but are not taking the exam. But anyway, good luck with all your future endeavors. Thank you all very much.